So now we come to 7.19. So the question says a quantity of 100 gram of ice, which is at 0 degrees Celsius, and 50 gram of steam at 100 degrees Celsius are added to a container that has 150 gram of water at 30 degrees Celsius, right? So a small little diagram will perhaps helps on figure out what's happening. So we have 100 gram of ice, okay? This is ice, which is 100 gram. Okay, that's in degrees Celsius, and there's a 50 gram of steam, so it's some form of gas, right? It is at 100 degrees Celsius. Okay, these two are allowed to enter a container which has 150 grams of water that is at 30 degrees Celsius. Okay, so that's our initial situation. That's our initial temperatures and different things we have, right? So determine the final temperature. So after this is added, what is the final temperature when they enter the container? And we are not worried about the container, right? So we are going to ignore that container is going to receive any heat from this process. Okay. So the three things or three characters which are there in the problem. So let's say there's some final temperature, right? Surely the steam is the highest temperature, so that is going to lose the energy, right? So my steam is going to lose the energy, okay? And that is going to do other parts of the things which is going to receive the energy, right? So we say the energy lost by the steam okay will be taken by, this is ice, right? So again by ice, so energy received by ice plus the energy received by this water. Okay, so energy received by water. As you can see, these are very simple law of conservation of energy applications, right? But as it is steam and it is 100 degrees Celsius, so first the steam has to transform into water, right? And then that water is going to fall in temperature to whatever final temperature T, right? So T is our final temperature, right? So this loss by the steam is going to happen, and basically it is going to that whatever energy it loses is going to be converted to first melt the ice, right? Then that ice is going to be, so I'm going to break it down into a little bit more detail now. Okay, so first steam on the left hand side, steam converts to water, right? And whatever energy that loses, right? And then water is going to cool down from 100 degrees Celsius to final temperature T, right? And in this process, both of them are going to lose that energy, and that is going to be received on the ice. So first my ice is going to melt, okay? And that melted water, its temperature will increase from 0 degrees to T degrees Celsius, okay? And third, the water which is there in the container already, right? In the container already, its temperature will also increase from 30 degrees to that particular T, okay? So the water in the container, right? It is going to increase its temperature from 30 degrees to T, right? And that is why how my energy conservation looks like. So we are going to simply write the equation for all of it, and then we are trying to find T, right? So first, starting with the steam. So steam is there is 50 grams of steam, right? So my mass of steam into the latent heat of vaporization this time, right? From steam to water, right? So latent heat of vaporization, right? So we are going to write mass of the steam, which is 50 grams. 50 grams, okay? So this is in kilograms into latent heat of evaporation of water, right? Which is again a very large number, which is double to 60 into 10 to the power 3 joules per kilogram, right? So that much will be from steam to water. And now it is water, which is going to go from 100 degrees to the final temperature T, right? So how much energy it will lose? It's going to be the same mass, which is again 50 by 1000, okay, multiplied by my specific heat for the water, which is going to be 4200, okay, and then the delta T is going to be final temperature is T, and then minus 100, right? So it is going to, in this case, because the left hand side, so my delta T is going to be from 100 to T, okay, and that is the energy on the left hand side, and that is going to be equal to on the right hand side. Now, how much is the ice we have been given? 100 grams, so which is 0.1 kilogram. Okay, now so into the latent heat of fusion for the ice. Latent heat of the fusion for the ice is, we know, again, a large number, so 334 into 10 to the power 3, right? So this is shorted. Now we go, all the ice now melts and becomes water, and that's going to raise its temperature, right? So the mass is same, 0.1 multiplied by now 4200, okay, and then the change in temperature is T, right, from 0 to T. And finally, the water which is there in the container, how much is the mass of that water? 150 grams, so that is 0.15 multiplied by, again, the specific heat for the water is 4200. This time the change in temperature is going to final temperature, right, is more T minus 30. Okay, so now you can see everything else is numbers and only the T is on the both the side. So we have to take the T, all the T's on one side and then try to solve it. And when you do that, basically we'll end up with T, which is going to be 95 degrees Celsius. So you can use your calculator to solve this, right? It's a very simple equation. So whatever is there, we can cut first and then try to solve this. Okay. So that way, you will be able to arrive at the T, which is 95 degrees Celsius, and that will be our final answer.